Hi there, this is Mr. Alexander, and today I would like to talk to you about adding and subtracting rational expressions. This is what we did in class on February the 19th and February the 20th. So, what you need to remember when you are adding and subtracting fractions that you must have the same denominator in every single fraction you are trying to add or subtract. In this case, the common denominator is a 3x, so we can go ahead and put this on the same fraction here with the denominator of a 3x, and we just say 2 plus 1 plus 7 is 10. So when you combine those, you end up with 10 over 3x. Let me show you something else then. So what if you have x squared over 2x plus 16 minus 64 over 2x plus 16. The first thing you need to do is make sure you've got a common denominator, and these both have a denominator of 2x plus 16. So when I subtract these, the denominator will be 2x plus 16, and I need to subtract the top. So that's x squared minus 64. Well, I can do a little bit of fancy mathematics here, because the top is the difference of two squares. That just factors to x plus 8, x minus 8. And the bottom has a common factor of a 2. So I'll factor out that 2. 2x divided by 2 is just x, and 16 divided by 2 is positive 8. So I can simplify a little bit here. Those x plus 8's cancel out, and I'm left with x minus 8 all divided by 2. These come with varying degrees of difficulty. So let me show you one that looks kind of bad, but maybe isn't so bad once you actually do it. Let's do 2x squared plus 5x divided by x squared plus 8x plus 16 minus 12 over x squared plus 8x plus 16. So I've got two fractions, and I have a common denominator of x squared plus 8x plus 16, so I can go ahead and write one fraction that's got the common denominator, and on the top, in the numerator, I'm just going to do 2x squared plus 5x minus 12. Now, you might be tempted to say we're done here, but we're not, because we can factor the top and the bottom. And when I'm factoring the top, whenever I've got a number in front of the x squared, I like to use the box method. Some people can do this in their head, but I like the box method. So I've got 2x squared, and I've got a minus 12 right there. And I need to start with a times c, which is 2 times negative 12, which is negative 24. So I'm looking for factors of negative 24 that add to positive 5. And the one that jumps out at me is 8 times negative 3, because that multiplies to negative 24, but it also adds to positive 5. So I'm going to write an 8x here and a negative 3x here. And now I'm just going to ask myself 4 questions. What do these guys have in common? That's just an x. What do these guys have in common? That looks like a 4. Here, they have a 2x in common. And here, they've got a negative 3 in common. So the fully factored form on the top there is x plus 4, 2x minus 3. Now on the bottom, I'm looking for two numbers that multiply to 16, but also add to 8. Of course, that's just 4 and 4. So this is x plus 4 times x plus 4. Now I can cancel some stuff out here. I can cancel out the x plus 4s. which means that my fully simplified solution here, 2x minus 3 over x plus 4. That's the answer. So far I've shown you 3 problems where you had a common denominator, but why don't we do a few where you don't have a common denominator? So I'm thinking in particular something simple to start. Let's go ahead and do 4x over 7 plus x over 21. Now what you're trying to do is find a common denominator. And in this case, 7 becomes a 21 when you multiply it by 3. So you can't just multiply the denominator by 3 though. In order to change the denominator without changing the entire number, you need to multiply the top and the bottom by 3. So this is going to be 3 times 4x over 3 times 7 plus x over 21. And I don't have to change this one at all because I'm changing this one to a 21 and that one's already a 21. So when I combine them, that means I'm going to have 12x over 21 plus x over 21. Now I'm ready to write them on the same fraction here. They're both over 21 now. Make that a straight line. 21. And 12x plus x is simply 13x over 21. That's the solution here. Let's do a few more like that. Something challenging. I'm thinking something like this. This looks promising. Let's do x plus 8 over 3x plus 5x plus 4 over 2x, and finally 7x plus 2 over 6x. And what I'm thinking we ought to do here is to make these all a common denominator, they all need to be 6x. So I need to multiply this fraction by 2 on the top and bottom, and this fraction by 3 on the top and bottom. So let's go 2 times x plus 8 over 2 times 3x plus 3 times 5x plus 4 over 3 times 2x. And since this is becoming 6x, all of them are becoming 6x, I'm not going to do anything to this one. Alright, so I'm just about ready to combine these. So they're all going to be over 6x. I know that, so let's just put them over there. And then 2 times x plus 8 is 2x plus 16. 3 times 5x plus 4 is 15x plus 12. And then, of course, I've got my 7x plus 2. So far, so good. Let's see here. I can combine like terms on the top. We've got 2x, 15x, and 7x. That adds to 24x. And then I've got 16 plus 12 plus 2. That adds to 30. And then I've got my 6x on the bottom still. You might be tempted to say we're done here, but we're not, because the last thing we need to do is take out the common multiple in all 3 of these terms. They all have a 6 that we can take out. So 24 divided by 6 is 4x. 30 divided by 6 is positive 5. And then, of course, 6x divided by 6 is just x. So it looks like this is that, fully simplified. Looks like I've got time for one more. Let's do something pretty challenging. that might rack your brain a little bit. Let's be the last one. 2x, start over, that was bad. 2x plus 5 over 6x squared plus 4 over 5x plus 3 minus 8x over 10x cubed. So the hardest part about this problem is picking a common denominator. And I'm looking at the 6x squared, that 5x, and that 10x cubed. And it looks like, as far as the numbers go, the lowest common number that we're going to be able to get out of that is 30. 6 times 5 is 30, and 3 times 10 is 30. And between x squared x and x cubed, we need to make them all x cubed. So I need to transform all of these into 30x cubes. I'm going to do that. To make a 6x squared into a 30x cubed, I'm going to multiply it by 5x. So I need to do that on the top and the bottom. To turn a 5x into a 30x cubed, I need to multiply by 6x squared on the top and the bottom. Still got the 4. To turn a 10x cubed into a 30x cubed, I just need to multiply by 3 on the top and the bottom. Okay. Now I know that all of these are going to be 30x cubed, so I can go ahead and put them on the same thing here. So 5x times 2x is 10x squared. 5x times 5 is 25x. 6x squared times 4 is 24x squared. And then finally, 3 times 3 is 9. 3 times negative 8 is negative 24x. And at this point, I'm going to want to combine like terms. And it looks like, I still got this 30x squared here. In terms of x squareds, I've got 10x squared and 24x squared, which puts me at 34x squared. And in terms of x's, I've got 25x's here, negative 24 here. So that's just going to be plus 1x. And in terms of constants, I've just got the positive 9. Now I'm looking at these numbers, this 34, the 1, the 9, the 30. There's no multiple that we can pull out of that. So at this point, I'd say we are done. And that is the process for adding and subtracting rational expressions. Thank you for watching. I hope it was helpful.